Well, you could just go to third period.
All right. So what's the other section? There you go. Noble gases. Okay. They used to be called the inert gases. Okay. They used to be called the inert gases. They've changed that since I started teaching because they've gotten 3 of the 6 gases to react with fluorine. Okay. Because those are so unreactive, they finally got 3 of them to react with fluorine, but that's all they've gotten to react with any of the other elements. Okay. They did, and let them react. They had to change the conditions, and it's very difficult, but they did get it to happen. All right. Beyond that, I think I'm done with what I want to do there. All right. So we're going to talk trends for the remainder of the class period. Now, this is the rest of our discussion on the periodic table, our trends. Now, this is where people struggle with this topic because y'all don't like to study. People come in and they go, Ms. Wall, I don't get it. This is where you have to study. And this is where the memorization piece comes in. And this is where the hardest part of this topic comes from. You have to learn the trends so you can apply the trends. For example, and don't write this one because we're going to do it tomorrow. One of the ones we're going to do is atomic radius tomorrow. Radius is about size. Okay? And how big something is. You have to learn that as you go this way, it gets smaller. And as you go this way, it gets bigger. So if this is the periodic table, and we look up there, helium is going to be small, and francium is going to be big. So if I give you 4 choices, you have to look at where they're at on the periodic table and figure out who's closer to francium will be the biggest, and who's closer to helium will be the smallest. But if you don't know this, can you figure out the answer? It's just a guess. It's eeny, meeny, miny, mo. Okay? That's why people struggle with this topic, because we're going to turn right around and do ionization energy, which is the opposite. Ionization energy is, as you go this way, it gets larger, and as you go this way, it gets smaller. Okay? Now, that's why people have a hard time with this topic. Now, today, we're not doing those. We're going to do something a little easier, I think. We're going to start with reactivity. Now, I like to start with this one because you already have a basis for reactivity. Okay? You already know some things. We started with this in the last unit we just did, right? Talked about outer shell electrons. Talked about who likes to lose or gain electrons, right? Talked about the 2 most reactive groups. We didn't talk about what happens as we go up or down the groups. That's the piece we want to add in today. Okay? So, we're going to start with reactivity, and we're going to only do metals on this particular slide. Okay? So, first of all, where are the metals? On the left side. They're on the left. Okay? So we know the metals are over here. Now,
is that small part where you do the transition metal?
Say what now? Yes. Whoops. And here, I'll even draw in the small part here and leave them out. Yes. Those are the transition elements. For the most part, we're going to focus on main group. We will refer to the D block sometimes because we are going to do a little bit with the D block. Y'all are an honors group, so we're not going to completely eliminate the D block because y'all, like I said, are honors. So we are going to sprinkle them in just a tad. So, what do we know about the metals? First of all, how far over into the metals do you think we should go? Is group 13 going to have a bunch of metals in them if we look at the periodic table over there? Look over there in your blue. How far does the blue really go that we need to worry about? Should we worry about group 13?
No. Yes.
How many metals are in blue over there in group 13? 4. I would count in group 13. Okay? So group 13, group 1, group 2, and the D block would be what I would consider metals. Now, when you get to group 14, there's only how many over there labeled blue? 2. I wouldn't worry about them too much. Okay? But at least through group 13, I would be worried about my metals. Everybody okay with that? Yes? No?
Yes.
Okay. So, what do we know happens based on what we've learned? Group 1 does what? What does it do? Okay, because? There you go. It only needs to lose 1 electron. All right, what's group 2 do?
Somewhat less.
Somewhat less because it needs to lose 2 electrons. All right, and what about group 13? Needs to lose 3. So will it be more reactive or less reactive? Less reactive. Okay, so we know that group 1 is what? Okay, so let me fix my staircase over here. It's bothering me. All right, so we know group 1 is more reactive than who? Groups 2, and I know somebody didn't just say group 3. What's that?
13.
Group 13. Now, because this does have some metals here and a little bit over there, we're going to call it the P block, okay? Because there are 1 or 2 there. More reactive than the P block. Now, who then would have the least reactive and most stable metals of all the metals?
14.
Well, the P we put here with the group 13. So who would be the most stable metals? Group was over here as the most reactive. These are the ones that y'all just said were the most reactive metals. So who would be the most stable metals? All right. The D block is going to be the most stable. Which is why we use the D block for a lot of things. Okay. A lot of the girls like to wear what? What do we use a lot of the D block elements for? Some of the guys will wear it, but you typically find it on more girls. Jewelry, okay? Because gold, silver, platinum, they're very stable. They don't react with a lot of things. So we don't have to worry that if we put our hands in things, that our rings are suddenly going to begin to dissolve or react with other things and be jerking our rings and things off because, oh my God, we just caused a reaction on our hands, okay? We don't have to worry about those things. We use copper in our pipes because we don't have to worry about what we put down the sink for the most part. Now, a lot of us use plastic or some type of polymer now. Now, lead, we've taken all kinds of lead out of pipes, even though we used it over here because it wasn't very reactive, because what's wrong with lead pipes?
Poison.
That's right, poisons us, causes us damage to our brain cells. You just try to set me off this morning. When did we take lead out of pencils?
Yeah, like 19.
Early 70s. Okay, we do not use lead pencils. It's graphite. It's carbon. Okay, for the same reason. Because let's say I got mad at one of my students. Would never do that. But let's say I did. I just jabbed you with a pencil. Or let's just say that one of our students got mad walking down the hallway. Xavier just made him mad. What? With a pencil. And a piece of lead broke off in their skin. What could happen to them throughout the day and over the course of the week?
Their brain cells get that.
Well, they could get lead poisoning and they could wind up seriously ill or possibly die at some point. However, we wouldn't want your brain cells to be dying off slowly or for you to become seriously ill and die. So we don't put lead in pencils anymore. It's graphite or carbon. You're not going to die from carbon or get carbon poisoning like in Star Wars. It's the same thing. I just refer to it as carbon. Graphite is carbon. Okay, but when I say graphite, sometimes some people don't know what I'm referring to, which is why I switch and call it carbon. Okay?
Who got a lead pencil?
Like being at home. Now, if I have these metals, what happens to the reactivity in the group? Are they all the same reactivity?
No.
No, what happens to them then? Do they get more reactive as you go up or down? That's right. You get more reactive as you go down. So, for example, in metals in group 1, so here, these explode in water. Okay? Group 1 elements explode in water. Stick them in water, kaboom. Sodium. Put it in water in a beaker and it explodes. It depends on how big the water is and how big the piece of sodium is. Okay? If it's a good sized piece of sodium and a beaker of water, big bomb. Okay?
What if I just throw it in a pool like this?
It would probably make a big. No. Now, let's say that I go down and I get something a little bigger like rubidium. Would rubidium make a bigger explosion or a smaller explosion? Bigger because it's further down the chart. It's going to be more reactive. Okay? Now, magnesium we had in class back in the first week of school, and I burned it and it made that bright white light. Okay? Would it explode in water? No. I have it sitting here on my desk. Okay? I could put this in water all day. It's not going to explode in water. It's still very reactive. I wouldn't want to put it in a flame because what would happen? It would explode and make that bright white light. It would burn the snot out of us if it got on our hand. If any of you have ever burned sparklers at the 4th of July, have any of you ever dropped it on your feet or anything? Burns like fire. Okay? Don't do that. Wear shoes. Okay? Now, because this explodes in water, it has to be stored in kerosene. Okay? Or in oil. It can't even sit on my desk. I'm not allowed to have it. It's one of those types of chemicals that high schools aren't allowed to have. All right? So we don't have any in the building, so don't ask me to put it in any water. If any of you take college chemistry, a lot of professors still keep it around, and they'll demonstrate it. It's a cool thing to do in a freshman lab class, to put a sliver of sodium in a beaker and let it spin around and make a little fire on top of the water. It's really neat. However, we're not allowed to do that in high school. You have to order it from a chemical company. Okay, I just can't be a high school teacher.
You gotta have some kind of license.
You cannot do it as Joe Q Public. No. Okay, so no. Now, would I have to store group 2 things in kerosene? No, they're not that reactive. Now, I've got magnesium, which is group 2 right here. Now, if we go over to group 13, everybody has aluminum foil. Does it have to be stored in kerosene? No. Some of us probably have gold or silver. Copper does not have to be stored that way, okay? Now, as you go down, it gets more reactive. Now, how do nonmetals work? All right, think about your nonmetals. Same concept, okay? Where are the nonmetals? On the right. All right, which group was most reactive?
One.
Thank you. I'm glad somebody else thought that was odd other than just Miss Wall. All right, so we've got group 18 here, group 17, 16, 15, 14, and 13. All right, so who would be the most reactive out of the non-metals? Okay, so the halogens are which one?
Group 17.
Okay, group 17, because they want to do what?
Get an extra.
Get an extra one, so they want to gain 1. Okay? They want to gain 1 electron. Okay? So they're more reactive than who?
14.
Group 18.
Group who?
18.
No!
They are.
They are.
They're more reactive than who?
All the other ones.
Which would be who next?
Group 16.
Yes! Group 16. Y'all jumped to like 15 and 14.
Yellow.
They want to gain 2, so group 16.
Don't react well under pressure.
And then who?
15.
And then group 15. Because they want to gain how many? They want to gain 3. Now, we can argue group 14 is next. But, you know, group 14, they want to gain or lose how many? They're really sort of in the middle at that point, okay? So, what happens to non-metals reactivity? Do they get more reactive as you go down? They get more reactive as you do what?
Go up.
Up, okay? These get more reactive as you go up. So, who would be the most reactive element for a non-metal?
Fluoride.
Do we agree with Tomas or no?
Yeah.
Look at the periodic table. He said fluorine.
Yeah.
I said, who is the most reactive non-metal?
AT.
All right, I got AT. I heard F and I heard CL. I hear more Fs. F is the right answer. Okay? Group 17 was who we said was the most reactive.
I did not say CL.
I know you didn't. I heard a CL. All right, and going up, so who's the top of group 17? Fluorine or F was the right answer. Okay? Chlorine would be the next most, but fluorine is the top. Okay? Everybody okay with that trend? All right. Now, the last trend we're going to do is nice because all of them work the same way. It's 4 and 1. Okay? 4 of them all work the same way. Does everybody have what they want on this board? Okay. So, this one is boiling point. Write a little darker. Boiling point. Melting point. Hardness. And density. Now, density, we've done this semester. Boiling point and melting point, we sort of touched on. We're going to do it again later this quarter. And hardness, we probably won't talk about again. You talked about it, or should have, in earth science, when you talked about maybe the Mohs scale with how hard rocks are. You can talk about how hard metals are. For example, in group 1, the ones we talked about which were really reactive, you can actually squish those with your fingers. All right, some of those are so soft, they're like butter. You can squish them. The D block elements are so hard that they're virtually unbreakable. For those of you who might one day want to buy wedding bands, they've come a long way in wedding bands, particularly for the gentlemen. Some of you are probably gold, platinum, silver kind of guys, but now you can buy tungsten, you can buy carbon type wedding bands. If you get the ones that are, I think it's titanium. Titanium cannot be resized. Many of you will discover as you age that what happens over time, your fingers get fat. If you buy one that's titanium, you cannot have it resized. So if you get fat, you will have to buy a new wedding band or have it cut off, or your fingers will eventually swell and you will have to have a new wedding band. A lot of wedding bands can be resized. Titanium is not one of those. Okay?
People don't recommend titanium.
Oh, no, people do all the time. Just keep that in mind. They're gorgeous wedding bands. It's just that, some people don't. They, stay very fit for years. But, not everybody stays the same size when they get married. Just keep that in mind. All right. So, what is the trend? We are only doing this, first of all, for metals. So, we're not going to do any of this for non-metals. Because when we talk about non-metals tomorrow, what you're going to find is nonmetals are solids, liquids, and gases. We cannot talk about the density of liquids and gases and solids and compare those in any way. So we're only doing this for metals. So when we compare this, where on the periodic table would the density, the hardness, and the melting and boiling points be the greatest? It's going to be the greatest where? The D block. D block is always going to be the greatest. Now, the next section of metals that will be the largest will be in the P block metals. Now, and I'm writing under it metals, because when I say P block, I want you to look over here. How many P block metals am I talking about?
6.
Yeah, like 6. We're just talking about a few P block metals over here. There's not a bunch of them, but there are a few P block metals that are going to be harder and more dense than the ones that are in group 1 and in group 2. Next will be group 2 and then group 1. So this one has the highest and this has the lowest. Now, does this look familiar or similar to something we already did? Does that look similar or familiar to something we already did? What? Reactivity of what? Metals. It looks just like reactivity of metals, except what?
The opposite.
It's the opposite. Okay? Did anybody see that besides Tomas and Tiffany?
No.
No. Okay. I'm doing a great job today. I need to step up my game. All right? So, when we look back here, the most reactive is group 1. The most stable is the D block. Same trend, except this one is opposite. The metals that are the highest in density, melting point, and hardness is the D block, and the lowest would be group 1. It's the same trend, except opposite. Okay? That's one way to help you learn that. There are several trends. You need to find ways to help yourself learn this. Okay? Are you with me?
Yeah.
Okay? You think you can practice it? Maybe. Okay. We're going to try it.
This
Uh-huh.
wall.
Yeah.
Why does helium make your voice high?
Oh, yeah.
I'm an biology teacher.
Isn't there a one that makes your voice really, really low
Yeah.
too?
It gets you like hot.
Which one is it?
I
It's
saw it on a
like high.
science video. I don't know, this professor, he was doing it, and then he started acting crazy.
Where did you mix helium? One of the suggested videos on YouTube. The one.
All right. Answer these 8 questions. You're going to need a periodic table you can see.
I said it kind of messes with the video.
Oh.
All right. Answer the 8.
What is it?
No, you
You can use your orange one or the ones we colored. It doesn't make any difference.
Oh, we got Jessica.
I'm glad we got just. I be getting tired of this.
I'm tired.
I'm glad you got whoever. Come on, answer my questions.
I bet.
Yeah. I think we should keep this until lunch. I don't know if I'm doing that. I'm sure to the concert. You just know, you go up, you know, really. What's number 17?
That's it say.
Which element will form an A, I don't know if this is -3 or dash 3.
It's a -3.
What does that mean?
-3 ion
Yeah.
has an oxidation number -3.
Okay, thank you.
All right, we done? Any more time? Where we at? I answered my email, so.
Yeah.
All right, Tomas is done. What about the rest of y'all?
Yes.
D-U-N-N. That's it.
Oh, I couldn't see it. It went right.
I have a right. Guess if the rock is good.
What you say? What she say, Tiffany? Nothing. And Tiffany, you better tell me.
Nothing. Yeah, she was a little closer.
Okay, we probably done it. I don't care. I think that's what you said. I don't care. My brain's full.
Oh, dang, okay, fine.
I am,
I can't see it all.
I'm sure.
See my eyes.
Alright. Give it caught up on some news. Alright, so if we look at question 1. Alright. Question 1 says, which metal's most reactive? What's the answer?
A.
A.
Hey,
Alright. Which elements are in group 1? Group 1's more reactive, so which elements are in group 1? Alright, so which elements are in the alkali metals?
oh,
Okay.
hydrogen.
I can make another copy of this for. Yes, I need a pen. I'm gonna write on it. Make it big enough Tomas can see it. All right. Is that big enough, Tomas?
Yeah.
All right. So where's CS?
Oh,
Group what?
1.
Where's CO?
D block. D block.
Okay. Where's CA? And where's LI? All right. So you got 2 in group 1. So how'd you know it was CS and not LI? It's farther down. That's what I wanted you to tell me. Okay. All right. So number 2, which non-metal is most reactive? Where's CL?
Yeah.
All right. Where's PB?
metal.
It's a metal. Okay.
Oh,
So if that's a metal, what do you know about that?
it's aluminum.
It's eliminated. Okay. N is what? Okay. And O. So what do you know is most reactive?
Nitrogen.
Okay. It's got to be group 17.
Oh. Oh, we can let these.
Okay. And sometimes I'll ask for least reactive. I just didn't there. All right. Which element has the largest density? What do we know about RB? Where's RB? All right. CR
D block.
and
Yeah.
aluminum.
13.
Okay. And not
17. Yeah.
and group 17. All right. So who's the largest density?
C.
Okay. Which one has the lowest boiling point? Where's aluminum?
13.
Okay. And group 13 is the same as the P block, by the way. All right. SN.
D block.
All right. And then NA
Group 1.
and BA.
Group 2.
Okay. So who's the lowest?
No. Yeah.
NA.
Y'all say B and then no? And then B? No?
Yeah.
Sure.
NA.
Okay.
Yeah.
I'm listening to Xavier up here. Yeah? No? Yeah? No?
No.
B when I was saying B, and I saw B
Okay.
when I said B.
Which element is the least reactive? Where's AL?
T block.
Okay. 13 or P block, either answer. NE?
B block.
18 is fine. All right. NA
1.
and CS.
1.
Okay. Least reactive. There's least reactive.
No, it's
Any.
NA.
Any.
because it doesn't react.
Yeah. It's empty.
Yeah.
It's NE. Okay. Why would it be NE?
It already has,
It already has 8.
has an octet.
Okay. Which metal has the highest melting point?
W.
Yeah.
All right. Why'd you pick W?
Because it's
So
a
it's in the
metal.
D block.
It's in the D block. All right. Does everybody see how we're doing those?
Yeah.
And the process we're going through to make that decision? You have to do that with every trend. But first you have to know the trend. That's why when people come in the next day and they're like, I don't get it. You have to know the trend in order to get it. All right. Which element has a -3 ion? That's the same as an oxidation number. Okay? So Al,
No.
what's Al's oxidation number?
+3.
What's zinc's oxidation number?
Where is it?
2.
Oh, 2 plus.
And what's nitrogen?
That's the one.
And what's silicon?
Plus or minus 4.
Uh-huh. So who has a -3?
3.
And
D.
I had that at first.
That would be correct.
3.
All right, and last one. Who has 3 outer shell electrons?
A.
A, Al.
So when you're losing, like when we wrote it down and it says lose 3 electrons, that means we're gaining 3 electrons.
Yes. If you lose 3, that means you have a positive oxidation number.
Okay.
Yes. If you gain, that means it's negative. And
These on the periodic table, these Roman numerals right under the groups, what do they represent?
those are the old numbering system for group name and group number. Some professors, if you take a university course and you have an older professor, will still use old system numbering for group name and number. If you have a younger person, they'll do it the way I do it with groups 1 through 18. But if you have somebody in their 50s or 60s, you're probably going to get the old number. Okay? And if you have somebody in their 70s, I know you'll get the old number. They'll call it group 2A, 1A, 7A, 8B. All right. We're going to do a Kahoot, and then we're going to talk about homework. All right. Go grab my keys off my desk, Tiffany.
Is it review on this?
Yeah.
Are we gonna be taking anyone else?
Yep.
You go down. What's original? Original.
No. I mean, I got the shit for free, so it doesn't matter. I still had to pay though.
You'll make a copy of what I.
Wait, I already have my laptop.
Oh, let's go. All right, come on, hurry up. I gotta have time to do the homework tonight too. Gotta have time to explain it.
How many questions?
This one's only 9, pretty short. All right, we're missing 2. We should have 18.
Yeah, sure. Yeah.
Nice.
Who am I waiting on?
Say. Who's that? And smile.
get caught up there. Not waiting on y'all all day.
Let's take a guess here.
Alright, not bad. Alright, the 5 of you who picked LI, we're in group 1, which is good. But what happens is you go down the group. They get more reactive. That's why it's RD. The one person who picked MG, I'm thinking probably just clicked on the wrong thing. Because that's in group 2. Alright, which non-metal is most reactive? Alright, not bad. BR is in group 17. Alright, one person picked CA, which I have no idea why that's in group 2. Maybe that's just an error. And the SE is in group 16, which is not as reactive as group 17. Alright, which element has the largest density?
What's the yellow one?
S.
Where's it going? Oh, well.
Right.
I couldn't find that.
Alright, very good. Alright, largest density is the D block. The one person who picked SR is in group 2.
But I was saying, where is it?
Group 2.
Oh, okay.
Group 2. It's not as dense as the D block. Alright. Which metal has the lowest boiling point? Alright, lowest boiling point. And that's TL, not TI. That's TL. Number 81.
Okay, how do you shoot?
It's number 81. That's why I pointed it out.
Is that L or L-I?
LI. The only L on there. Would be something we've used. Okay, that's not terrible. Alright, group 1 has the lowest boiling point, melting point, density, and hardness. Alright, group 2 is the next lowest. Alright, but this would be the highest, and that would be the next highest. Alright, which metal is the least reactive?
What's the yellow one?
Yellow one is AG. 47.
Okay. Oh, shoot.
Alright. So the 5 people who picked K didn't pick least reactive, they picked what? They picked most reactive. They're at the wrong end of the tree. Okay, the question was least reactive. And you guys pick most reactive. All right, which metal has the highest boiling point?
Where is
Highest boiling point should be where? Should be in the D block, but I didn't give you a D block, did I? So who should be the next highest? The P block. So the P block would be the GA. Okay, so that's GA. And so that's why it's the yellow. CA is in group 2, which would be next. But this is your P block element, which is why it's the yellow. Then CA, then CS. Oxygen's a non-metal. So the person who picked, oh, that's a non-metal. It can't be a metal. Okay, which element forms a -1 ion? This one I better have 100%.
Oh, you're not going to the ground school. Right. I get it confused.
All right.
If it says you lose electron, that means it's a plus.
It's a plus one.
Okay,
Yes.
that's what
Yes. Okay. So those of you who picked this one, that's +1. This is -1. All right. Which element will lose 3 electrons to achieve an octet? It will lose 3 electrons.
Oh my God. I'm so dumb.
That is terrible. All right. So you guys have to remember. Okay? All right, my periodic table's a little jacked up there. All right, this group does what? It loses 1, loses 2, loses 3, loses or gains 4, gains 3, gains 2, gains 1, neither. Okay? So, who will lose 3? Right here. Who's in this group right here?
Aluminum.
Aluminum. That's why it's aluminum.
Aluminum.
Okay? All right. Last question. Which element is the most stable? Can't find who? RN's in group 18, RH is like 46, 45, RA's group 2, and PB's in group 14. Some of them have gone back and put the atomic number in, but I have it there. Most stable. Most stable means you need to be where? You need to be in group 18, but at least the 5 of you who picked the D block, that's at least something. All right? The 2 of you who are in group 2 and group 14, I don't know what's going on there. But the D block is not as stable as group 18. Group 18 is always going to be more stable. See how the question just says which element is more stable? If it says metal, then choose the D block. But because it just says it's a blanket statement, which element, group 18 is always more stable than that. All right, so our top scorers were those guys. Okay?
Thank you.
All right, let's talk homework. While you're putting up your laptop, since Eduardo and Sophie playing on their phones, I'm going to make them my able-bodied assistants again. Because they did such a great job of not forgetting themselves, unlike my people I picked in third period right here. I got fired. No, y'all did great. Third period who mopped it up yesterday, I got to fire them and get new people. They were terrible.
Give me that, Ms. Ross. I was up there this time.
You weren't. It was very good.
Thank you.
It was very good. Abraham can apparently fish and play good.
I wasn't fishing.
Were you in the paper for fishing?
Oh yeah, he was there too. I was there. I wasn't fishing. I was,
Okay.
I was
So you just hanging out?
He was eating pizza. Yeah, I
Oh,
could.
okay. Yeah, they didn't want to take a picture of people eating pizza apparently.
I tried it, and I'm not patient enough to fish.
Did you guys anything to say?
No.
No.
Then we had a home run.
Oh, okay.
Limit the long.
Oh yeah, I'm turning in my homework.
Oh, no, homework passes
That
homework.
was fun.
Why not? Why not? Why not?
Quiz grade.
It's just a quiz grade.
Or white, or what? I don't have no green, yellow.
All right, everybody got what they need?
Weirdo.
You should have 2 papers on your
I
desk.
need one more.
What you asking? All yellow. Oh, that is one of those yellow. Don't alternate.
All right, we don't have a lot of time, so everybody needs to be quiet and listen for 10 minutes so you know what you're doing tonight. First of all, ACT boot camp passes will not work on this, so don't bring them to me. All right, these are quiz grades. They are being graded for right and wrong answers. Okay? They are not, everybody hear me say it, not able to be made up if you don't bring them to me tomorrow. When you get here tomorrow, you have to turn them in at the beginning of class. If you choose not to give them to me at the start of class because you didn't do that, you take zeros on which, Xavier, I know you hear me talking, I'm loud.
That loud?
I'm pretty loud. Sam.
Do you?
Now, if you choose not to do them and bring them back, and you're here tomorrow, you don't get grades for them. You cannot make them up at a later date. They're the only assignments pretty much all year that work that way. Now, I'm just being honest. They are not homework grades, they're quiz grades. You heard me say that, right?
They're two separate.
They're 2 separate quiz
We're
grades.
gonna have both of them done tomorrow.
Yes. Are you not planning to look at the directions and follow along with us so you know what you're doing over there, James? Now, if we look at the first one, the one that says the scavenger hunt. If you look at the directions, they're a little on the cheesy side, but I've cut down the cheese tremendously from the way it used to be. Now, it tells you that you're friends of Dimitri Mendeleev, and you've been magically transported into his 18-room castle. Now, it says that no element is repeated, and you are using the first 3 periods of the periodic table. Now, the first 3 periods have how many elements?
The first 3 periods.
The first 3 periods have how many elements?
Like 9?
Oh my God.
Oh, yeah.
The first 3 periods have how many elements? I heard it. 18. How many questions are on the sheet? 18. So, no answer was what?
Repeat.
Repeated. No answer may come outside of the first 3 periods. Okay? So that means your answers have to be above potassium. So hydrogen, helium, sodium, magnesium, through argon. Can you pick potassium as an answer?
No.
It's in the 4th period. No. People will give me manganese as an answer. Manganese is where?
In the
In the 4th period. It is not eligible to be an answer. Does everybody understand that?
Yes.
Okay. Now, just to illustrate how easy some of these questions are. You are transported in the castle. A holographic image of Mendeleev is going to follow you on your journey. So question 1 says, you suddenly materialize into a room made of shiny metallic solid. The room has been constructed of a lightweight, corrosion-resistant material composed of atoms containing 3 valence electrons and 13 protons. It's the most abundant element in the Earth's crust. What element are you? Now, we should all be able to answer that. Look at a periodic table and tell me who I am. Aluminum. What's the only element with 13 protons?
Aluminum.
Now, not all of them are that easy. However, every answer is used how many times?
One time.
Okay, now some of you people are stupid.
Wow.
You're going to do the work faithfully because that's the kind of student you are. And then some of you are just not because that's the kind of student you are. And tomorrow during first period, somebody's going to say to you, can I see your homework? If you hand it to them, that's on you. Okay? You do the work and give your work out, that's on you. Now, the second paper, we have not done yet. You're going to have to do a little work on your own. Okay? So, periodic trends in atomic radius. You're going to draw a graph. I'm going to help you for here a minute, because some of you are going to look at this and be like, oh, I draw a graph. Yeah, you do. You learn how to draw a graph in middle school. Turn your graph sideways. Okay? You're going to count by 2s across your x-axis.
See the line in between or just?
No, count by 2s. So 0 in the origin, and then 2, 4, 6, 8. If you put a line between, it's like counting by 1s. You're going to run out of space and be attaching a paper on the end. It's going to be like a fold-out sheet. Okay? On your x-axis. Pitch 4. Only got to go to pitch 4. Okay? You don't have to keep doing all that right now. If you started by 2, stop for a minute. On your y-axis, you got to get to about 2.2. So we need to count by about 0.1. So start with 0 at the origin again. You go like 0.1, 0.2, 0.3, 0.4. Now, you see how you're skipping all those lines right there, genius? You are never going to get to 54 counting by like that. Each line has to be 2. So 2, 4, 6, 8, 10.
What did you say we had to get to this?
About 2.2. Now, and again, if you started on the track of 0.1, 0.2, 0.3, you'll be able to finish that on your own for later. Look at the front side. Okay? You see all these numbers right here in the middle of this page. There are 54 points there that have to be graphed. No, I've not lost my mind. Yes, I know how many points there are. I've graphed it myself.
You'll look at every single little point.
I will not look at every single little point, but I can tell at a quick scan whether you did it right. Now, if you look at these points, you're going to plot them, and I would strongly recommend as you plot, you connect, or they start to look like a jumble. It is not a straight line, okay? It's going to be all up and down, okay? You do not have to label each point by writing the letter above the points so you know what the element is above the points. I will tell you that now. I would label the noble gases just to make life easier for you when you get to questions. After you've labeled and drawn the graph, you have to answer the analysis questions below it, okay?
How do you do that? Okay. I do like that.
So like 1.
It's like the
If you really
Point started.
That is
Plot the
H
points.
is point.
Never mind, I see it now, I got it now.
So what now? If you need help with the questions, you are all very bright
So
people.
like we can,
Look up some stuff on Atomic Radius if you get stuck.
We can like put a dot in between like the line, like 131. It can be.
Estimate?
Yeah,
Yeah.
thank you.
Wow. Okay. Any questions on the homework assignment tonight? Or what it counts for? Okay. If you want to do labs today, because I know a couple of you said you were coming, please come by. I'll be here till about 4:15, 4:20. I don't want to stay really late today, given I have to be here till 7 o'clock tomorrow night. Please invite your parents to come by and see me. I will be here for 6 hours tomorrow. I might as well have somebody to visit with. Right?
No.
Yes.
No.
I will be bored senseless. Tell your parents to come see me.
I don't see a point.
If nothing else, just so I can say hello.
She just wants to say hello.
You
I'm
said
sure
we
they're
can
nice
only go
people.
up to, just go up to 54?
54 is as high as you're gonna need.
Okay.
'Cause
And
there's
then
nothing-
2.2?
Yeah, I don't think there's anything higher than 2.2 if I remember right. And I know there's nothing higher than 54.